In the beginning was the Big Bang of creation. Around 14 billion years ago, the universe expanded from a primordial dot to fill the cosmos with stars and galaxies today. Now concentrations of energy not seen since the first trillionth of a second after the Big Bang are to be generated here on Earth in a vast machine near Geneva. This is the Large Hadron Collider, or the LHC, where hadron refers to the class of subatomic particles that includes the proton, a basic unit of matter. The LHC will do something quite simple: record what happens when protons are smashed together. Beams of protons circulate in a tunnel 17 miles long, about 100 meters below the Swiss-French border. The collisions take place in 4 huge detectors, which you can think of as the eyes of the machine. Each proton has about the energy of the motion of a flea, but there are enough in the beam to deliver the same energy as a 400-ton train at 90+ miles an hour. When these protons smash together, they'll generate a slew of new discoveries about the universe. In the fallout, 2 of the detectors hope to find evidence of the Higgs particle, which explains why some things are heavy and other things are light. By this view, a particle gains mass because a Higgs particle latches onto it like a celebrity's most sycophantic fans. Scientists also hope to answer a mystery about dark matter, which was first discovered more than 70 years ago. We still don't know what dark matter is, but evidence for its presence is overwhelming in observations of the way its gravitational tug influences the movement of galaxies. Candidates for dark matter could be found if a menagerie of new particles emerges at the LHC. When scientists look at the fine details of the collisions in the vast machine, they may also find evidence that there are more than 3 dimensions of space. Some theories suggest that space is actually 10-dimensional. Every apparent point in our 3-dimensional space, if hugely magnified, may actually have some complex structure, a tightly wound origami in extra dimensions. Perhaps the longest shot of all is that this project will back string theory. By this idea, the universe is not made of tiny point-like particles, but of tiny vibrating pieces of string, each about 1/1000th of a billionth of a billionth of a billionth of a centimetre long. Some theoreticians consider it the best hope for a theory of everything, a theory of all the forces of nature. But this is a voyage into the unknown, and there's still an outside chance that the £4.4 billion Large Hadron Collider will find absolutely nothing at all.